So now let's take a look at 1t. Now you take a look at this expression, and our first tendency may be to try to use substitution again and do something like that. I don't think I would, just because now I'm trying to replace one thing with one thing. I don't think that that is a good way to deal with that. We're not really going to simplify it. Notice if you did replace all of your 3x's with an a, you're still going to produce a quartic equation, and you don't have the means to solve every quartic, so I don't think I would bother. Instead, what I want to try to do is I want to try to see, can I expand some of those brackets to produce two of the same term? So let's just say that I did 3x minus 5 times one of those 3x plus 1s. So I'm just going to examine this, because I do notice that when I do that, I do get 9x squareds, and I will get the same thing if I went and I expanded those last ones. However, when I do this, I'm going to get a positive 3, a negative 12x middle term, and we should be able to clearly see that if I were to expand the other 3x plus 1 with the 3x plus 7, I will get my 9x squared, but I'm going to get positive terms there, and they won't be the same thing as that bracket. So trying to go through and pair them up in that way becomes difficult because they don't give me the same middle term. So rather than following those red and gold arrows up top, instead what I'm going to do is I'm going to try the blue. I'm going to multiply the first binomial with the last one. When I expand that, I'm going to get a 9x squared, and then I get 21 minus my 15 is a positive 6. And I love seeing that, because when I then expand my perfect square, I now get both brackets, and within those brackets, I have the same first two terms. So this becomes a great problem for us to try to then say, well, why don't I let a equal 9x squared plus 6x? And now that can become an a minus 35 times an a plus 1. And now you take a look at that blue. Well, now if you expand that, you get a quadratic, and you do have the means to solve every quadratic. So something kind of quirky to look at in T. I think you can probably finish off T as well. Okay, hopefully those help you, and keep working through your practice. I hope it continues to go well.